Good morning, developers. If you are new to the channel, my name is Rob, and if you are a JavaScript developer or the web is your primary playground as a developer, there's a good chance that you feel left out of this machine learning AI frenzy that's going on right now. At least as of the making of this video, it seems like everybody's saying that's what you have to learn. That's how you're going to stay relevant. It's good reason, right, if you feel that way, because several years ago when I started going down this road, JavaScript just wasn't at the front and still kind of isn't. You have to pick up Python. You have to go learn some library and a bunch of concepts and vocabulary that you don't understand. It's going to take months to get even the tiniest thing down. You're going to need lots of data and so on. Okay, and that's not the case, right? JavaScript in the browser can do some awesome stuff. And facial recognition and detection is what we're going to talk about in this video. And whether that is the thing that you're interested in, you're in the right place. Or if you're a JavaScript person and just are interested in AI, but you don't know quite where to start, this is how it started for me. I was doing WebRTC. I needed to do some facial recognition on the video. I didn't know what a model was. I didn't know how to make one, all of that stuff. And this is how I got into it, right? A small step into a really, really big concept. So you're in the right place in either case. Just to break down kind of how the video is going to go, we are going to use face-api.js. That is built on top of TensorFlow. Why don't we use TensorFlow? Well, that's normally what I would teach is the native thing, but teaching TensorFlow up front would be like teaching React to someone who's learning JavaScript today for the first time. Right? There's way too many levers and knobs and buttons and gauges. That's not the right place to start. We want something that's simpler, where the models are already built, where we don't have to train stuff, and we can just slowly start to build on some concepts and get to a place where we can start filling in the gaps. Okay, it's not going to be crazy exhaustive. The API is going to be able to do a lot more than what I'm able to show you. We're not going crazy deep or crazy wide, but we're going to straddle that place in between the tutorial that assumes you have a PhD in machine learning and the one where you code along but nothing is ever explained. So when you get to the end, well, yeah, it works only because I copied everything you did, but I could never do it myself. We want to be in between there where you'll be able to walk away from this with the ability to implement this. Because Face API, it can do emotions, it can do age and gender. You can do lots of really cool stuff with it on a webcam, on videos and so on, and we're going to be limited to an image in this video. So watch further videos or check the description for other links. But we're going to break the process up into two pieces. The first thing that we are going to do is facial detection. This is pretty obvious. We give it an image, and that image can come from lots of places. We can pull it straight out of the DOM. You could use an input and upload a file that way. You could get it from the file structure or a URL or something like that. But let's say our image has two people in it, our stick figures here. The facial detection uses a neural network. Fancy machine learning term. If you don't know what that is, don't worry. It breaks the image up into a bunch of layers, does some math, and figures out where are their faces in here using math. And what it will do is draw what are called bounding boxes around the outside. Okay, so we've got bounding boxes, and this is a common term in programming, I would say, just because it's easiest to use like a Cartesian, just an X and a Y coordinate when you're talking about something graphically like an image or whatever. We've got a bounding box, and that bounding box is also going to have a score for how confident is our library, is our neural network that this is a face. So maybe we get like a 0.99 and we get a 0.84. The higher the score is going to be more dependent on, is the person looking straight ahead, how prominent are their features versus, is there rain in front of them, etc. Right? There's lots of things that can make it higher or lower. We will get both of those, and we can actually draw those using Canvas on top of our images, which is pretty cool. We need to be able to do a little bit more work, so we're going to do something called facial landmarks. So these bounding boxes, they may not quite be aligned, or they may grab more than they need to. And in order to maximize our facial recognition chances, increase probabilities, we want the bounding box to be as centered and as small around the actual face as possible. So the landmarks, you definitely have seen images like this where you've got a person So here's a face. I'm not a cartoonist, even though this kind of looks cartoony. But the person has eyes, of course, a nose, and a mouth. The dots along the jawline, Face API uses 68 to create these landmarks. And they're going to be like around the eyes, around the nose, etc., to determine where the face is at specifically, if it's looking in a particular direction, follow movement. If we're on a webcam, we're not, we're going to use an image, but the landmark will be important. So again, we can center this and make sure that it is in the right spot. Make sure our bounding box is in the right spot. Let me clean this up quick. So we've done our facial detection. The next step is going to be the facial recognition. And recognition, of course, requires us to have some other images in order to compare them to. So we'll have one, maybe two, maybe 10, whatever it is, other images of faces that we have some kind of metadata associated with, right? So I've got this face. Face API has pulled this out, or TensorFlow, whatever you want to call it. Check it against this one. And that uses, if you want to do some research, dlib, or ResNet, these are architectures that it employs in order to use math or geometry to figure out, is this face the same one as this? And this will also come back with a score. We'll set a threshold, and whatever that threshold is, if we're above or below, it will identify as yes or no. Maybe it comes up here, and this one's like a 0.79, and we say, okay, that's close enough. And bam, we've got our match. We'll do the same thing with this, and we get a 0.91 or something like that, okay? This is going to use what are called facial descriptors. And we're not going to go into a lot of detail on what these are. I'm giving them to you so that you're familiar with them. And if you want to Google them or keep looking around, you sure can. But that is enough to compare it to some other image, whether that is this person is smiling here and they're crying here, or whether this person is by themselves up here and they're in a huge group here. Whatever it is, we've got the facial detection element, the facial recognition element, and that is everything we need to go start coding. Let's go knock this out. Over to github.com before we start coding, a few repositories I want to show you. First of all is Face API, and I'll drop all these links in the description. But Face API, this is the library we are using. You don't need any of these files because I have them in another one for you. We will be back here, but the main file is in dist, and then it's face-api.min.js. Again, I've already got that, so you don't need that. Weights, these are the models that we are going to use. This is again the library. All the work has already been done with TensorFlow and the modeling and so on with the machine learning. If you scroll down, it's not real clear documentation. That's not, I don't think, what it's meant to be, and that's why I am here, is to help you out. But you can look through this. We'll come back and look at available models in a second. The other one, this is the starter files, or the structure already built for this video. So I would like you to download this however you download it. I don't normally like doing this. I like to start from scratch, but there's some HTML that we just don't need to get, and then the file structure, it will save a lot of headaches by just starting off. I will walk through every single file here in just a second. If you click on code and then download zip, if you don't normally get code from GitHub, that is the best or the fastest way. Please open up the contents, or open up the file structure in your code editor, and I will meet you back here. So I am over at Visual Studio Code. That is the code editor I'm going to use. Anything you want to use is fine. I am also on my Windows machine. The reason I bring that up is because I did include a Node.js server. And you say, why did you do that, Rob? This is all front end. Well, yes, everything we're going to do is index.html and scripts.js. But sometimes this doesn't work when you run it directly from the hard drive, like file : ///. So I built a 4-line Express.js web server for us to use. If you don't have Node.js, hopefully it will work without this, and you can just open up index.html directly. Otherwise, I would like you to come over to your terminal. Again, I'm using PowerShell and run npm install. Again, if you've got Node.js, that should do the trick. You can run node or nodemon, whichever one you've got, on server.js. We want to make sure there are no errors. And then if you come over to localhost 5000, this is what you should get loaded up. This sweet old man drinking coffee, and then a line 1 on scripts.js here. Okay? again, what Server's doing, I got Express. I made an app from Express. We're serving up everything inside of public statically. So what we're looking at here is index.html. And then on line 4, we're listening for traffic on port 5000. So we come back over here, localhost 5000 is going to load up. You can put in here index.html, and there we go. Okay, so what do we have inside of public that's going on? And real quick, node modules, this is here because we just ran npm install over here. Git ignore and readme, those are github.com things, so ignore those. The package.json is where npm install looked to decide about Express. And then I already talked about the server, okay? We're not gonna do anything with any of those files. Public is where everything is loading from, okay? And images. This is gonna be facial recognition and detection, so I generated a bunch of images with an AI generator. Now, that theoretically means there shouldn't be any copyright issues, but there might be, because that seems to be a hot topic these days. I tried to give you kind of a wide breadth so that if you want to play around with these, you can and kind of see what it's made of without having to go chase some files down. Okay, so that's what's in images. Models, these are the actual machine learning data that has already been trained. So this is the model that's going to do the work for us. If we come back over quick to the repository, if you click on available models, there is detail down at the bottom about the facial recognition and the detection. So this first one, SSD MobileNet V1, it goes over just how this works. The face detection, you can do a little bit of research. Tiny face detector is the other one. The landmark, we talked about that. That's the points around the outside of the face. The face recognition model, as I mentioned, this uses ResNet, or it's based on ResNet or dlib. There's a couple links here, as I mentioned. The age and gender model, and so on. So if you want to look through this and do a little bit more legwork and some reading, that stuff is there. But back over here, you can see the name of the file indicates what those are. So you can't view this because it's binary, but these shards here, this is the age and gender one, the face expression one, and so on, okay? That is really the guts of the machine learning part of it. FaceAPI.min.js is the JavaScript itself so that we can interact with it, okay? I don't want to keep that file open any longer than we have to, but inside of index.html, we have down at the bottom, we're including face-api.min.js. That is going to use the models, which we are going to load in just a second inside of scripts, okay? Line 15, it loads up scripts.js. I have two single style tags here, an image and a canvas tag. We're going to need a canvas to be able to draw the bounding box. You'll see that in a little bit. And then here's line 10 is our canvas, and then line 12 is what's making that old man show up. So that should put us in good shape. I want you to keep scripts.js open up. Line 1 is face API. So if we come back over here, that's what is showing up here. That's all the stuff that comes with using face API. So we have this thing because we included it back here in index.html right here. Line 14 is why we have this line here on line 1. I've got on line 3 a run function, and the reason that this is here is because we need to load our models, and we're going to use await to do that. And we can't run await at the top level, so we call run. Run is an async method. Everything we do is going to be inside of run. We'll back over to the video repository. So this is mine, face-api.js starter. I have this code here loading the 4 primary models. I want you to copy this code, and I want you to drop it inside of run, okay? And we'll talk through it here quickly. Again, we're using await. Promise.all means we're going to hand it a whole bunch of async operations and don't move forward until all of these are done. What are we doing? Well, we're going to faceapi.net and we're loading one at a time from the models directory these 4 models. There might be more. I might add some more in this lecture, but we're at least starting with these the facial detection one here, the landmark one, which is the dots, face recognition so we can do the matching, and then the age gender one as well, okay? we need to make sure that this works, so please come back over and refresh and make sure you don't get any errors, okay? If you do, work through them. But again, I've already got everything set up so that the models folder, it's referencing locally. You maybe can get rid of that and just go straight to it without the /, but you should be in good shape and we should be loading all four models. The first thing that we're going to do is play with the bounding box. So we're going to grab our old man's face and draw the box around it, and then play with it a little bit. So the first thing, let's do image. Actually, let's call it face 1. We're going to go document.getElementById. We're going to grab face. So if we come back over to index, let me keep this one open. I have an ID of face on this image, so we're going to grab this DOM element and we're going to interact with it. There's a couple different ways you can grab images. We'll grab one from a URL in a second, but this will grab the actual DOM element. We are going to take that thing and we are going to hand it to face-api. So we're going to do let face AI data. So this is a variable we're going to make. Please use let because we're going to overwrite this here in a minute. This is an await as well. face-api.detect all faces, and then we're going to hand it face 1. Okay, we're going to add a few things to this, but we grab the image and hand it to detect all faces method. We're gonna add a couple things. We're gonna change some things onto that. Okay, we're gonna do with face descriptors. That's gonna allow us to do the facial recognition or the matching. That's that 128 points, the geometry. We're also gonna do with face landmarks. That is, oh, and then that's open close as well. Face landmarks are the points on the face, and then we're gonna do with age and gender open close. That is going to use that model as well. So we included our models right here, line 6 through 11, loaded them up. Again, this is binary data that's already been run. It's already been trained on what the human face looks like and so on. We're grabbing the image out of the DOM, line 13. Line 15, we're going to grab all the faces in this image. There's only going to be one. And we are going to use this model, the face descriptors, which we loaded right here. It's going to use face landmarks, which we loaded up there, and then the age and gender, which we loaded up there as well. Okay, so if you would like to just test that out, we can console.log our face AI data, hop back over, refresh, and it looks like I made a mistake. I believe we need to switch the order around so that face landmarks comes first. So I'm going to cut that, and I'm going to put that right on face 1. So the first thing will be dot with face landmarks, open close, then with face descriptors, and then we'll have age and gender. Okay, so let's try that again. That is my fault. They have to be in that order. And you can see here line 16. It pops back an array of one item, and it shows the expected age of the face that it found. 80 years old. I have no idea how old this person is. Again, it was generated by AI. But then it's got a bunch of stuff. So the descriptors, the detection, the gender probability, the landmarks, and then the aligned rectangle. That is what we're going to draw right now. We want to draw the box around his face so that we can see where it actually went, or what it's drawing the data off of. So we have our data. I'm going to comment out line 16 for now, and we need to do some canvas work. So get the canvas and set it on top of the image and make it the same size. So this is just JavaScript stuff. This is not in any way artificial intelligence or face API stuff. This is just canvas. So we're going to do const canvas equals document.getElementById. Grab the thing with the ID of canvas. So back over to index.html. That's line 10 here. Come down a line. We're going to do canvas.style.left equals, well, we grabbed face 1 up here. That is our DOM element. So we're going to go to that thing and use its offset left. We're going to copy that. We're going to do the same thing for the top. So we'll have style.top is offset.top. Okay, and again, what this is going to do is it's going to take the top left corner of the canvas and set it on the top left corner of our image. Again, face 1 is the image that we have pulled back. Okay, the next thing we're going to do is make them the same size. And we can do that with canvas.height equals, it'll be face1.height, and then canvas.width equals face1.width. Okay, so please get these 5 lines in. So grab the canvas and then basically just update it. If we come back over here, before I refresh, I'm going to hover over the canvas. You can see it's up in the corner there, 300 by 150. If I refresh the page now and I hover over top of it, it covers the entire thing, and it's sitting on top of the image exactly. So in index.html, remember I had shown you this briefly, but we have position absolute on canvas. The reason for that is because we want to draw on the image, and the canvas is transparent, so we've got the canvas now sitting on top of our image. So let's make a note. Let's draw our bounding box on our, we'll do face/image. FaceAPI.draw detections open close. We hand this our canvas, which we just made up here, and then we hand it our AI data from line 15. Okay, so FaceAPI.draw. This draw detections method is going to use the canvas, that's our first argument, and it's going to use the data in our second argument to actually draw that on the canvas. So if we come back over and refresh, we get a nice bounding box, and it says 0.9 above it. Now, you can see it's not in the right place. Why not? Well, when the canvas was initially created and when the image was initially drawn and so on, we just can't guarantee that everything is exactly where it should be. So there is another function that we can run here quick. I mentioned we were going to overwrite face AI data. That's why we did a let here. We're going to do face AI data equals face API dot resize results. We're going to hand it the face API data, or the face AI data, which we just did, and then we're also going to hand it our image itself. So we're going to hand face1. So overwrite our artificial intelligence data here, our machine learning, our detection, whatever you want to call it, pass that very thing to resize results as well as the image so that these two things are matched up. Okay, so if we refresh it now, the bounding box is sitting on his face. Now there's two good things about this. I mentioned we're using the landmark here to make sure that we have only grabbed the maximum amount that we need for any of our other models. So it is shrunk down, so it's not quite his whole head, and it is sitting right over the most important part of his face, which is exactly what we want. Something fun we can do now is if we come back over to index.html, if we pull old man 1 out of this and do waterfall 1, that picture, coming back over to the browser and refresh, this has a ton of people in it. And I think this is really interesting to see. Again, this was generated by AI. Let me get rid of that for a minute. Some of the faces are a little blurry. Some of them are looking different directions. Some of them have, some weather in front of them. So it's not totally sure about some of them, but it pulls back. Let's drop in here our AI data again. So I'm gonna console.log that. Do a quick refresh, and it grabbed 32 faces out of here, all with varying degrees of confidence that this is a face. And 0.5 or 0.6 seems to be kind of the standard for this is probably a face. We're not going to get into any of that at the moment, but I'm going to comment this out. I think I actually had it up above. I did. But we have drawn our detections. You can play around with this. Like I said, you can do old man 2, come back over and refresh. It'll draw the box on, this time it's 89. You can look through whatever images you've got as well. But as I said, another option here is we can load the image from a URL. So instead of on face 1, here's line 13, I'm going to comment that line out. And I'm going to do const face 1, await face API.fetch image, and then you can hand it any URL you want, whether it's on your hard drive or whether it is a URL. If we come back over to the video repo here, Face API Starter, I'm sorry if you don't like these two people. I have two of Ronaldo and one of Elon Musk. I did a quick search. They're the most recognizable faces in the world, so I'm going to grab this first one of Ronaldo. You can copy it however you want to, or you can grab your own. Images are not hard to find, but I'm going to paste this in. And so face 1 is now going to be Ronaldo's face. Now, the catch is, inside of index.html, we need to update this, so I'm going to paste that in here as well. Otherwise, the bounding box is going to be on our old man's face, which won't make any sense. So there we go. It's 94. It's got a 94 there on that first one. You can grab the other Ronaldo one if you want. I'll grab the Elon Musk one, copy it. We need to change it in both places. Again, otherwise the box isn't going to be in the right place. So change the face we're going to grab as well as the DOM element. Refresh it. We get Elon Musk. There we go. That's a solid one. 99 is high. So let's do the age and gender part now. Coming down below all of our drawing. Okay, so we're down here below draw detections. I'm going to drop a comment in here. Ask AI to get the age and gender. Let's do guess, because that's very much what it's going to be based on how it's trained. But we take our face AI data and we're going to do dot for each. Now we only have one face in this particular one, but we'll call the one we're on face, and we're going to grab a couple things out of this. Okay, so face comes with age, gender, and then a probability. Those need to be spelled correctly because we're destructuring the object here. Those are going to come out of face, and then we're gonna make a new object here. We're going to do new face API.draw. We did the same thing up above, but instead of draw detections, we are going to do draw text field. Open, close. And draw text field is what gives us the little blue box or the blue number up there. We want to put on here age, gender, and probability. If you want, you can write this directly into the DOM. It makes no difference. That's all this is really going to do is put some stuff in HTML. We hand this thing an array, and the array is gonna be a DOM element for each line in the blue box. So I will show you here quick. We'll do gender text equals. I am using Grave, so we can go into a template literal mode here. So we'll grab gender, and then I'm going to put a dash, and then we will go into. I am sorry, it's not probability. What we want here is gender probability, and so it's going to look like that. So that's our gender text. Right below that, we'll do our age text, and we'll put here age. And this is always going to come in years, so I'll put the word years after it. And it's also going to come back in a ridiculous float with our decimal point. So let's do math.round, and we'll hand it age like that. Okay? So face AI data dot for each. So loop through every face that we found. Grab the face that you're on and run this code. Grab out of the face the age, the gender, and the gender probability. Well, the reason we have that stuff is because up here, we included the age and gender model, which is the trained data. And then when we detected the faces here on line 17, we have with age and gender. So we have included that as an option. Otherwise, it's going to say unknown for everything. We grab all three of those out. We just build two variables to make life a little bit easier. Gender text is going to be gender dash and then whatever the gender probability is. Age text, which we're just rounding the number of age and then putting the word years. We just drop those in here. So it'll be gender text followed by age text. So we're going to have two lines. And then we actually need to add one more thing at the end of our array. We need to tell it where to draw this. And we're going to do face.detection.box.bottom left. Okay? The face is the thing that we are working on, right? That's the particular face that it found, the box that it drew. The dot detection, we looked at that briefly. If you want to pull that back up, you can see, but the box is the bounding box that it has drawn. We're just saying put it at the bottom left. And then at the very end, we're going to do a dot draw, and then we're going to hand it our canvas. Let's do this. We'll do a const text field. We will set that equal to our text object here. And then I'm going to move this down. I'll go over this again here in just a sec as I'm changing some things. I know that's hard to see. We've got our gender text. That's just a template literal, right? We're just building a string. Our text field is a new face-api.draw and then draw text field. We hand it our array of our two elements. We tell it where we want to draw. And then this text field we're going to call dot draw, and we're going to hand it our canvas. Our canvas, again, is this thing up here, line 22. Okay, let's come back over and refresh. And for Elon Musk, at the bottom left of our our bounding box there, it guessed with 0.99, so theoretically 99.3% sure that he's male, and it's guessing him to be 54. If you wanted to round off the gender probability, you'd want to cut a couple decimal places off. Don't use math.round because it will round it up to 1 or down to 0, which won't be very useful. But that is a cool way. If you want to change where it's at, instead of bottom left, you could do top right. Come back over and refresh again, and you'll see it's up here. Again, it's just one line for each element in our array. If we come back up top here, I'm going to comment out face 1. We will grab our old man, come back over to index.html, and I'm going to switch this back over to our old man and refresh. Okay, there we go. It's quite sure he's male, and it thinks he's 71 years old. We can grab old man 1 and see what that looks like. Play with this as much as you would like to. I think this is really fun. It's guessing him 81, even though it's supposed to be the same man. Okay, so lastly, back over to scripts. The last thing that we can do here is do face recognition. And really what this means is check to see if one face matches another, because face detection is easy. You've already seen that. We have our bounding box, and you can do that on as many faces as you want. I'll grab our index actually, and I'll throw waterfall 1 back up there while I'm talking. But the key here, and we should have loads, it's all over the place. Hard to actually make any sense out of that. But back to our facial recognition issue. Once you've detected the faces, this part really depends on your application. How do you want to do it? Ultimately, all you're going to do is just check the descriptors, the points on the face, to see if they match. So back over to our waterfall image, it could be this is an old image and a bunch of your friends are in here and you don't remember their names. So you're going to loop through each face one at a time. Again, pull the geometry out, compare it to our database. So we'll loop through, grab one face, and then loop through all the database of faces and compare until we find a match and we know that person's name. If it was a spy movie or something like that, you maybe have an image of a person, you don't know who it is, and you start looping through all of the known database images that you've got, and you look for any match, and then whatever. We can't do everything. So what we're going to do is I've got 2 new images in our repository here. This first one, the bottom one, this is Michael Jordan, a basketball player. We know who this is. We have one face here. It is an outstanding image of him. This is what we are going to use as our reference. The other one is 3 people, different height. Is Michael Jordan in that picture? And if he is, which one is he? Let's draw him on the screen, okay? That is going to be our facial recognition application. And instead of changing these 2 files, I'd like to leave them. This is essentially our facial detection, and I'll put that back up at the top. I'll get rid of line 2 here. Facial detection. I am going to copy this whole file, and I'm going to make a new file called let's call it fr-scripts.js. So fr for facial recognition. I'm going to paste it in there. We'll clean it up in just a second. And I'm going to make a new index called fr-index.html. I'm going to copy index as it is right now into our fr index. And the 2 things I'm going to change in fr index, we're going to point at fr-scripts, and then I'm going to go over and I'm going to grab the image of faces. So we want to know, is Michael Jordan in there? Of course, you should use whatever images you want, but I'm going to paste that one in here over our waterfall. Okay, so it looks like that. And if I come back over to localhost 5000, instead of index.html, it's going to be fr-index. And I've got that image loading up now. Everything should be broken. Actually, it says tainted canvases may not be loaded. We're pulling images from other places, and fiddling with the canvas is why it's upset. We're going to use the same image, so it'll be fine. So let's grab this other image here. This is our reference image. Back over to our code. I'm going to get rid of index and scripts. We don't need this anymore because we've put our the correct image in there, and we've linked up our JavaScript file. So I am going to delete everything up to our canvas, and I think we can leave the rest. So that was I think that was mostly the gender and the age guessing. We still have our run, and I'll change this from facial detection to facial recognition. We still need our models. We don't need this one anymore. You can delete it. I will leave it for now. Face 1, I'm going to delete this one, and we'll load this from our link. So face 1, I'm going to change to reference face, and we'll make a note here. Reference face equals, we know this is Michael Jordan, or whoever you've used, right? This is our standard. We know for sure who's in this picture. I'm going to change this from our Elon Musk picture to our Michael Jordan reference picture. I'm going to copy this, paste it in, and we'll put in, instead of our reference face, we'll do faces to check. And this is going to be our other image, this one. And I'm going to paste that one in here. So those are our two images. The next one there, we grab the image and hand it to detect all faces. So we're going to grab the reference image, and I'm going to change our variable name here. Instead of face AI data, let's do reference or ref face AI data. Change that to a lowercase I. And instead of handing it face 1, we're going to do reference face. Right? Just some variable changes so that if you come back and look, this will make more sense. We still have to grab the geometry, right, the descriptors out of our reference face so that we can compare them to each face inside of faces to check. So we still have to detect. We're going to copy this line. I'm going to paste it in. I'm going to get rid of with, age, and gender for both of them because we don't care about that. I'm going to paste it though, and instead of the reference face, we'll do faces to check AI data, and we're going to hand that, line 15, faces to check. So you can console.log those if you want to, but what we are after here is get me the descriptors, all the geometry out of our reference, grab all of the faces, there's only going to be one here, and then grab all the faces here, do the same thing. And we still need our canvas, line 24. We can, before we check for errors, there's a face API method called match dimensions. We can hand that our canvas, and then we'll hand it our faces to check image, and it will resize it and place it for us. So we did all the height and the offset stuff. Line 25, match dimensions, does the exact same thing. So let's come back over to localhost 5000, refresh, make sure that, oh, I'm going to misspelled canvas there. I'm sure you noticed that. Let me refresh again. We just want to make sure we don't have that tainted error. I do not. If I go to the canvas, it is in the right place. Okay, this is where you need to be. Back over here, what do we do now that we've got our canvas, we've got our AI data, we've got our images? We need to make a FaceMathcher. So that is going to be our main task, and this is the part that you need to remember when you want to do this on your own. We will do let FaceMathcher equals a new face-api.FaceMathcher, and then we're going to hand it our reference face AI data. So FaceMathcher is a constructor in face API. We hand it our reference AI data. So this is all the stuff. We know this is Michael Jordan. We're going to make a FaceMathcher, and then we're going to use this thing against all of the different faces inside of this one here, line 19. Okay? One more thing I want to do. Let's grab faces to check AI data, and let's resize that. We did this in the other one, but we're going to call resize and hand it that exact same data. And then let's grab our faces to check just to make sure that it worked. I think it works fine on mine, but just in case you run into that issue, this will save you a headache. We're going to overwrite our AI data, just resize it to make sure that it matches that image. Okay, so we've got our FaceMathcher, we've got our AI data. Let's make a comment here because this is the important part. Loop through all of the faces in our image to check and
compared to our reference data. So grab this thing, faces to check AI data, do a dot for each. We'll call the one we're on face, and we're going to run this code on all of them. Let's pull out of there detection as well as the descriptor, and that's going to come from each face. So we're just destructuring again. Face.descriptor, face.detection. We just have convenience variables here. The detection is the bounding box. That's so that we can draw on it. The descriptor are the points on the face that we're going to use. We are going to make a label, and there is a constructor to do this, but I'm not going to do it in this video. We could potentially do it in another one, or you can look at the documentation, but you can make your own label. We're going to make a label using the default that comes out of Face API, and you'll see here what I mean in a minute. But we'll do let label equals. I'm going to grab our FaceMathcher. So this was defined back up here on line 30. That has Michael Jordan's, we know his face is in that. Call find best match, and we're going to hand it the descriptor data we pulled out there of the face that we're on. So we're looping through those three faces. Those three faces have descriptors and detection. Hand each descriptor to the find best match function of our FaceMathcher, which is definitely Michael Jordan's face. So grab the math from the current face, see if it matches the one that we know within an acceptable threshold. Okay? And we're going to do at the end of this to string, and I will show you what that looks like. Let's console.log our label. Line 38, we have gone through all of our images, and we're looking for the best match for this particular one. So refresh, and I made a small mistake there, line 31. It is not resize, it is resize results. So that's line 31 should be resize results. Let's try that again. We're looking for all of our labels. Okay, so it hit unknown for all the faces. It looks like it found 1, 2, 3, 4, 5, 6, 7 faces in there, which is pretty amazing because I would have said there are 3, but it sees the audience members apparently. Person 1, that is the made-up label that it used because we're not going to do the constructor. We're going to change that to Michael Jordan. So, I'm going to comment out line 38. Let options equal. We're going to have a property of label, and I'm going to put in there a value of Jordan. We're going to make a draw box, and we did this before. We're going to draw the detection box, the bounding box. So new face-api.draw box, open close, hand it detection.box. We got detection back up here from the current face that we're on. So detection face, and I spelled detection wrong. There we go. And then hand it options, which is basically just going to be our label. Okay? We take our draw box, run .draw, and hand it our canvas just like we did before. This part, hopefully, you remember from the first part of the video, we are going to draw the bounding box around the face of the person that we matched with. So coming back over and refreshing. Okay, we get Jordan over everybody because we always change the label. Obviously, we don't want to do that. Instead, we'll do an if statement. If the label, which is line 37 here, if label dot includes the word unknown, then we are simply going to return. We don't want to draw a bounding box if we don't know who the person is. At least I'm not going to. So I'm just going to kill it. Otherwise, we will go ahead and change the label. So if I refresh one more time, there we go. It correctly identified Michael Jordan. And if you want to see the level of confidence, you can console.log the best match up here. So I guess it'll be line 38. I'll bring that back in. Refresh one last time here. And okay, there we go. So it has a 0.55 there for that this is in fact Michael Jordan. Up to you if you want to keep that in and if you want to play with it a little bit more. This is exciting stuff. I think this is super awesome. We're implementing machine learning or AI. We're not necessarily building it. We use TensorFlow for that. You can look for other videos I've got, or you can always send me post a comment if you want to see something in particular. But this is a great startup for doing facial recognition with a much simpler API. enjoy it. Continue to look at the documentation. I will link a couple videos that you can take a look at, but thank you for watching.